Welcome back to another exciting chemistry video lessons. In the previous lessons, we learned how to calculate for molar mass of any substance, and we assumed that the coefficient is always 1 because the molar mass is the number of grams in 1 mole of that substance. Now we are going to take that same knowledge and apply it to conversion factor to exchange between moles and grams. Well, let's solve an example problem. In this case, we are looking at the conversion factor between moles and grams for this particular chemicals, and it doesn't have a coefficient there at all. Well, we know it is always 1. Here we have the actual problem. How many grams of calcium carbonate are there in 3.5 moles of calcium carbonate? So what I have here is calcium carbonate, and I have a sample of it, right? And I tell you there are 3 moles of calcium carbonate. We only know in terms of mole, but what about the grams? Well, that's pretty easy. We can measure the grams of calcium carbonate using a scale, okay, or a balance. That's one way we can do it. But what happens when you don't have a scales or a balance? Well, we can actually calculate this and theoretically solve for how many grams of calcium carbonate are there using our knowledge about molar mass and conversion factor. Well, let's go back and solve for this molar mass. And look at this. I already did the basic work for you already. Calcium. How many calcium do we have? We have 1 calcium. And we just take that and multiply by the average atomic mass on the periodic table, which is 40.08. And then for carbon, we have 1 carbon. And for carbon, the average atomic mass is 12.01. And remember the unit for this is AMU. And AMU is equivalent to grams. So we can exchange unit AMU or grams. Either one is fine. Then lastly, we have oxygen, which in this case is 16. So the next step is we just multiply to find the total mass for each element in this substance using our calculator. So for this one, it's pretty easy. 40.08. This one is 12.01. And then 3 times 16 give us 48.0. And to find the total mass of the whole entire thing in grams, we just add all the mass of each element together. So we have 40.08 plus 12.01 plus 48.0. And that turned out to be 100.09. Now for step 2, we kind of scaffold you through this process, and you're going to rewrite this as a conversion factor in this particular format because we need to see molar mass as a conversion factor. Again, molar mass is always 1 mole. So 1 mole of that substance, in this case 1 mole of calcium carbonate, CaCO3, is equal to the number of G. G is what? G is the abbreviation for grams. So in this case, what do we have? We have 100.09 G of CaCO3. Now we have our conversion factor that allows it to convert from grams to mole or between moles and grams. And let's solve this problem. Remember the same strategy that we did before? Take your given, time your conversion factor as many as needed until you get your desired unit. In this case, what is your desired unit? Well, the desired unit is what? It's grams. What is your given? You are given 3.5 mole. So let's start plug into this equation. We have 3.5 mole of CaCO3. And time our conversion factor. Remember, there are 2 parts to the conversion factor where the measurement are equivalent in values. Look at this one. This is a unit mole, and we want to solve for grams. So this mole is going to be on the bottom right here. So we have 1 mole of CaCO3. What's the top part? Well, the top part is the remainder part. There's only one place to go. It's on top. So 100.09 grams of CaCO3. Look at this. Mole of calcium carbonate. The whole entire chemicals simplify into 1. Just like we have X over X equal to 1. Now we just have something more complicated. The whole entire thing functions as a variable, just like X. So when we multiply, we just multiply everything on top, divide everything on the bottom, and we can ignore the 1. So we have 3.5 times 100.09 and divide by 1, which we can ignore. And what we have here is 350.315. So we're going to round to 2 decimal places, okay? So we have 350.32. And what's the unit? Well, the units right here, this is the only unit that's left. Grams of calcium carbonate. And that's how we combine the concept of conversion factor and molar mass to solve for grams from a given amount to a mole. Let's try another problem. In this case, the same format, we have the conversion factor between grams and moles from this chemicals, which is ammonium oxide. And of course what we have here is, we have the elements from the periodic table. And in this case, let's go back and look for nitrogen. Nitrogen, see right there, that 2 tell you there are 2 nitrogen. So we have 2 times, and what's the value for nitrogen? For 14.01. And oxygen right here, we just have 1 oxygen. So 1 times, so 16.00. And then for hydrogen, how many hydrogen do we have? Well, 2 times 2, what's that going to be? Well, that's going to be 8 times 1.01. And we do the math. So 2 times 14.01, that is turned out to be 28.02, easy math. And 1 times 16, that is even easier. And then we have 8 times 1.01, that turned out to be 8.08. Oh, easy math. Now let's use our calculator to add all of them together. We have 28.02 plus 16 plus 8.08. And that turned out to be 52.1. And we're going to keep 2 decimal places. So this case is going to be grams of, what is this? Well, ammonium oxide. In this part, I just want you to type in the total. Now, let's rewrite this as a conversion factor. Of course, always 1 mole of the substance, which in this case, NH4, or ammonium oxide, equal to how many grams? We have 52.10 grams of NH4, which is ammonium, and then oxide. And now let's look at the problem. How many moles of ammonium oxide are there in 23.25 grams of ammonium oxide? So in this case, I have this sample right here, right? If I draw this out, I have this sample right there. And we use a scale that tell us, what is this? 23.25 grams. And that is the reading on a scale. But we want to figure out how many moles, because mole is an extremely important unit in chemistry. We can measure the gram easily, but getting the moles, there are no instrument that can measure mole directly. We can only measure gram and then convert to mole. Now this becomes very important. So the same thing, how many mole is it gonna be? But using our knowledge about conversion factor and molar mass, now we can solve this. Starting from your given, as always, right? Your given time the conversion factor until you get your desired unit. So in this case, we have 23.35 grams of ammonium, again, oxide, time our conversion factor. Notice how this is now grams, so this has to be on the bottom because we need to cancel that out. We are solving for mole, so 52.1 grams of NH4O, and the top part would be this part right here. So 1 mole of NH4O. Look at this, gram of ammonium oxide cancel out, just like we have X divided by X. This whole entire thing is just like X, okay? So now we use a calculator, multiply everything on top, and divide everything on the bottom. We can ignore the 1. But in this case, we're just going to do it, just to show to you. 23, oh, this is supposed to be 25, my bad. Okay, no problem. So we have 23.25 multiplied by 1, divide everything on the bottom. So this is 52.1. So we have 0.446 we're going to round to 2 decimal places. So that is going to be 0.45. And what is the unit going to be? Well, the unit is going to be mole of NH420. And that is how you use your knowledge about conversion factors and molar mass to convert from gram to mole or mole to gram.